Hello again. We're going to do some row reduction and allocation. So here we go. Let's start her off. We have this situation. I've got some people, A, B, C, and D, and I've got they're doing some tasks 1, 2, 3, and 4. And this is the number of hours it takes for each of them to do. And I've just got to try and work out which job it's best to give which person to make it all as quick as possible. So we go like this. First we're going to use row reduction. That is, we're going to make all these rows look smaller numbers and get some zeros in there and see what it looks like. So the first thing is I'm going to look in each row. So I'll look at the top row, row A, and I'm going to find the smallest number, which of course is 4. And I'm going to take that away from each of those other numbers. So taking 4 away in that first row, 4 from 5 gives me 1 and 1. 4 from 4 is 0 and 4 from 7 is 3. So that's what we're doing here is called row reduction. Now in the next row the smallest number is 6, so I take that away from everything. And that gives me a 0 there, and then 4, and then 2, and then 3. The next row it's 5, so 5 from 13 is 8, 0, 4, and 0. And the last one, the smallest number is 5, so I take that from 8 and I get 3, 0, 5, and 6. Okay. Now, once you've done your row reduction, you have to pause and have a look and see what you've got. Now there is a 0 in every column. You now have to see how many straight lines, vertical or horizontal, you can put through those so that you cover up all the zeros. And you want to do it in as few a number as you possibly can. So if I were to put one straight line across that way, that'll get rid of those 2 zeros. Now I've got 3 more in 3 different. I'm going to have to use 2, 3, and 4 straight lines to cover up all of my zeros. Now because it takes 4 and I've got a 4 by 4 grid here, I have finished doing my row reduction and column reduction. I didn't need to do any column reduction in this case, and I can go straight to the allocation stage. If you can cover up all your zeros with just 3 lines or just 2 lines, then you have to go and carry on doing more reductions, or you have to use the Hungarian method. But for now, because I've got 1, 2, 3, 4 straight lines, and that's the only way to cover up all those zeros, I now go to the allocation part of this problem. So let me carry on and do that. The allocation part of this problem means that if I just put in, this is person A, B, C, and D, and this is job 1, 2, 3, and 4. Person A, where its 0 is going to do job 3. So person A is going to do job 3. Person B is going to do job, that's job 1. Person C is going to do, and I've got a choice here, they can either be doing 2 or 4. And person D, they're doing job 2. So I just got to, it's pretty clear what's going to happen here with these. A is going to do 3, B is going to do 1, C can do 2 or 4, and D can only do 2. So D of course will do 2, and C will do 4. And now to work out the minimum time this is all going to take, well, if person A is doing job 3, if I go back to my original picture, person A and job 3 is there, and that takes 4 hours. Person B is doing job 1, that's that one there, and that takes 6 hours. Person C is doing job 4, and that takes 5 hours. And person D is doing job 2, and that takes 5 hours as well. So the total length of times 10 and 10 is 20 hours. And that is the minimum time we can get all these 4 jobs done by these 4 people. Okay, so that was just a straight row reduction question and then the allocation. And I'll do another video somewhere where I have to actually use the Hungarian method, which is the next stage on from this. Okay, that's that.